Alright, hello everyone, this is Mr. Crozier, and your assignment today is just to continue working on page 2 of this. You can print this out if you have a printer, or you can just do the problems on a separate sheet of paper. When we get back to class, we'll go over all of them, and I have copies in class. So this is page 2. Well, page 2 says, starts off by graphing this. We have to graph this equation here. Well, we take these points and we plug them in for x, and we figure out the values, and we go ahead and graph it. So I'll just do a couple of them. Some of them, let's see, if I plug a 0 in here, 2 to the 0 is 1, so that's a point on our graph. And what if we go all the way out here to 3? We put 2 to the third would be 2 times 2, that'd be 8. And then what about negative 3? So if I go 2 to the negative 3, well, that's still an 8, but it's 1/8. Alright, so now we have enough points to go ahead and graph this. And remember, you always want to try and scale this as best you can. So I have to go, let's do the x first. I have to go out to 3. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I only need 3, so 10 divided by 3 is 3 1/3. So why don't I just go 3? 1, 2, 3, that's 1. 1, 2, 3, that's 2. 1, 2, 3, that's 3 all the way out there. And I'll go negative the same way. 1, 2, 3, 1, 2, 3, 1, 2, negative 3. And then going up, I just have to get to 8. 1, 2, 3, 4, 5, 6, 7, 8. Might as well just do that to 8. And going down, negative 8. 1, 2, 3, 4, 5, 6, 7, negative 8. Alright, plot your points. Remember, the asymptote is whatever this value is right here, and it's plus 0. So if I were to draw an asymptote on here, it would be right there. And then it's going up, so I'm just going to go ahead and draw some kind of line in here. It's going to be somewhere in that direction. But again, plot your points to make sure. Alright, solve this exponential equation as a proof. Well, we have this equation here, and our reason is always given, and then we have to go ahead and solve it. And the only formula we know is that if a to the m equals a to the n, then the exponents are the same. So we have to get the bases the same, so the exponents are the same. Well, this is 5, and 25 is in the family of 5, so why don't I just go ahead and make that a 5 squared. And what do we write here? We rewrite the base. And then now we have 5 and 5, but we need an exponent there, or we need to fix this exponent. So why don't we just distribute this in here? And we have 6x minus 10. And what's that called? That's called power to power. And now what do we have? Same bases, same exponents. 2x plus 1 is equal to 6x minus 10. I'm going to write it all out. If a to the m equals a to the n, then what? Then m equals n. And we did some abbreviations for this. We did some names for that, but then this also works. Alright, you can go ahead and solve that equation from there. Let's see here. Same thing here. We have 7 and 49. We could make this into 7 squared. And solve that. We can make this 3 squared and 3 cubed. I'll let you finish it. And this one right here, we have 1/3 and 9. They're both base 3, because this is 3 to the negative 1, and 9 is 3 to the second. So I got the bases the same for you. Go ahead and put the exponents in. Do this power to power rule if needed. Then bring it down, and then you can solve the equation from there. All right. Bring this back to class tomorrow, and hopefully we'll go over it.